Okay, it's now time to put a recap on our mixture tables. Here's some of the various problems you should be able to solve. The members of an outing club take a tubing trip down a river. The company offers small and large tubes for a trip. Large tubes cost $15, while the small tubes cost $75. So that means one of each would be $15 and $7.50 respectively. The club spends $360 for a total of 26 tubes. Find how many large tubes and how many small tubes were purchased. So I'm finding large tubes and small tubes. Okay, and this is a pretty obvious 3-unit problem because we have the small, the large, and then the money. So that's 3 units, so we need our table. So small, large, total, how many, our cost for a single, and then our total cost. Okay, so when I look in here, I know the cost for a small is $7.50. Cross that out. The cost of a large is $15. Okay, so how many small tubes are there? Well, the only thing I see about how many is 26 tubes. And it doesn't say more than, so it can't go for small or large. So that's 26. And then that can be X and Y. And then our total money is going to be $360. Okay, so that's going to be 7.50 times X, and then this is going to be 15Y. So I now have a system of equations I can write. X plus Y equals 26. And 7.50X plus 15Y equals 360. Okay, so these have ones as multipliers, so we can multiply by 7.50 up here and by 1 down here. Okay, so 1 times 7.50 is 7.50x, and then 1 times 7.50 is 7.50y. Okay, and then 26 times 7.50 gives me 195. Okay, and the bottoms are going to remain the same. So 7.50x plus 15y equals 360. Okay, so we'll multiply these all. Okay, these are all the same. So negative, 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 and these can be canceled. So I add, and that gives me negative 7.5y, and this is going to be negative 165. Okay, then we divide by negative 7.5, and y ends up being equal to 22. Okay, so my large tubes, there was 22 of them. Okay, now to get your other answer, if you know this is 22, you can just take 26 minus 22, or you can put it in the original first equation. Okay, so 22. We need to multiply those two, so that's going to be 22 plus 1x. Then minus 22, minus 22. 26 minus 22 is 4. Okay, so that's how to handle that one. That should be pretty, we should know how to do that one. Okay, now it gets a little tougher. These are kind of newer ones. How many ounces of a combination of 20% hydrochloric acid solution and 70% hydrochloric acid solution need to be mixed to obtain 20 ounces of a 50% hydrochloric acid solution? So these are percentage mixtures. Now, with percents, we want to list our percents, okay? If there's only 2, list them, and then that's our total. But if I have 3, like I do here, I want to put the smallest one, the largest one, and then the middle one, which is 50%. Okay, now we only need labels on the sides here with these percents. There's the original and the percent itself, okay? So let's do all our percents, 0.20, 0.70, 0.50. Okay, the original amount, or sorry, don't write original, sorry, put the label ounces. Okay, now the only ounces I see is 20, and that is of 50%, so we put 20 here. Okay, so I don't know these, and then I can just fill out the bottom. So 20% of X plus 70% of Y, whatever equals whatever 50% of 20 is, which is 10. Okay. Okay, so I got a nice system here. The X plus Y equals 20, and 0.20X plus 0.70Y equals 10. Okay, and we'll be putting ones in here, multiplying all these by 0.20. So 0.20x plus 0.20y. 20 times 0.2 is 4. Okay, and then the bottom will just remain the same. So negative, negative, negative. So I add 0.20 plus negative 0.70, and that's going to be negative 0.5y. Okay, and this is negative 6, and then I divide. And I divide negative 6 by 0.5. Means how many 0.5s go into 6, and it's 12. Okay, so Y is 12. Now how to label that? It's 20 ounces at 70%. Okay, now to get your X, you can just take 20 minus 12. That's what I'm going to do. I'm going to take 20 minus 12, because I know if that's 12, 20 minus 12 is 8. Okay, so X equals 8 ounces at 20%. Okay, next up, I'm not doing this one. It's just like that small tubes, large tubes problem. I've done that a bunch of times. Okay, a bank loans out $60,000. Part of it is loaned at 12% interest, part of it at 14% interest. If the interest received is $7,700, how much was loaned out at each rate? So again, percent mixtures, but this time there's only 2. So I've got the 12%, the 14%, and if I don't have a third percent, I'm just going to write total. And then the unit is money, and then the percents. Okay, so we know our percents are 0.12 and 0.14. Now the only money I see 2 of them, but we got to put the right one on the top row. Okay, there's 2 of them. One goes on top, one goes on bottom. Okay, well, the original money that we deposited, we want to pick the higher amount because that's what I started off depositing. And then when I applied interest to it, that's what we ended with. So this can be X, this can be Y, so it's 0.12X. Remember to put your larger amount goes here, and then the interest, the little part that came out as interest goes here, not little, 7,700, and then 0.14Y. Remember, how much was loaned out, the amount of the loan goes up here, and then the interest down here. Okay, so I've got X plus Y equals 6. I'm going to repeat that again because I think that's really important. I have 2 different money labels, but one of them goes in the total, in your beginning total, 60,000. And then when the percents are applied, that's how you get your interest out of it. So 12% of X plus 14% of Y equals my interest, 7,700. So I'm going to multiply all these by 0.12 and these by 1. So 0.12X plus 0.12Y, and then I find 12% of 60,000, and I get 7,200. Okay, and then my bottom, 0.12X plus 0.14Y equals 7,700. Okay, so I make the bottoms all into negatives, and then we add 0.12 plus negative 0.14, negative 0.02. You need to write that entire decimal. Then 7,200 plus negative 7,700 is negative 500. divide. Okay, so negative 500 divided by negative 0.02 is $25,000. Because y is money, and that was at 14%. Write what percent it's from. Okay. And then to find the x, you can take 60,000. If you know that's 25,000, you can just take 60,000 minus 25,000. That's 35,000. And the x that's at 12%. Okay, next one. The manager of a Starbucks store is mixing Colombian coffee, which sells for $5. This one's not about percents, it's about units. Manager of a Starbucks store is mixing Colombian coffee, which sells for $5 per pound, with Arabica coffee that sells for $10 per pound. At the end of the month, we have 50 pounds of Arabica coffee left. Nobody wants to buy that, but if I mix it with some Colombian coffee, okay, mix the rest of the pounds with Colombian coffee, he's going to sell the new blend for $8.50 per pound, kind of between these two. How many pounds of Colombian coffee should be in this new mixture to make the same as separate? Okay, so I want to just find one answer. It's pounds of Colombian coffee. Okay, so I have the pounds of the Colombian, but there's also another kind of pounds of the Arabica, and then money, so it's a unit chart. Okay, so totals in the corners, and then how many, and single. So money single, money total, and then I've got Colombian and Arabica. Okay, so I want to find the cost for a single pound, means per pound. So the Colombian coffee is $5 per pound. And the Arabica coffee by itself is $10 per pound. Okay, the only how many I see is 50, but that is the Arabica coffee. Okay, 50 pounds of the Arabica coffee. Okay, so the Colombian coffee I don't know, so that's X. So cross out both 50s. And I see this $8.50, but that's per pound. Well, that's when they mix it together. Okay, so we're going to put that in for our total. So that's 5x, and that's 500. Now, I have nothing here, but I can write it because total, how many total? We take our x pounds we have of Colombian, we add our 50 pounds of Arabica. Okay, and then you do your distributive property. So 1x times 850 is 8.50x. And then I take 50 times 8.50. That's going to give me 425. Okay, now what I want to know is how many pounds do they have to sell to get total together to make these equal out? Okay, they want to make the same to get together when they mix them as they do separately. So basically I want to know when 5x plus 500 is going to equal 8.50x plus 425. So my x's, there's the same kind of x, so get those together. So I've got 500 equals 3.50x plus 425. Now I subtract 425. That's 75 equals $3.50 times x. So I divide by 350. And 75 divided by 3.50 is 21.4. Okay, next up. Scientist wants to make 6 milliliters of a 30% sulfuric acid solution. The solution needs to be made from a combination of 20% sulfuric acid and 50% sulfuric acid. How many milliliters of each solution must be combined to make 30% solution? Okay, so again, percents. And how many of them do I have? I have 1, 2, and 3. So I put the smallest and then the highest, and then we're going to put them in the same bucket. And in the bucket, we want 30% of the sulfuric acid. So with percents, you just look at your label, milliliters, that's what it comes in, and then percents. The bottom kind of works itself out. So 0.20, 0.50, and 0.30. Okay, so the only milliliters I see is 6, and that's of the 30, so that means I can call that X and Y. So 20% of X plus 50% of Y, and I need to take 6 times 0.30, because 30% of those 6 ounces need to be actual sulfuric acid, so that's 1.8. So it's a system. So X plus Y equals 6, and 20% of X plus 50% of Y equals 1.8. Okay, so I multiply the tops all by 0.20. So 0.20X plus 0.20Y. And then 6 times 0.20 is 1.2. Okay, and then the bottom equation just remains the same. Okay, reverse signs so that you have opposite x's to cancel the x's from the system. 0.20 plus negative 0.50 is negative 0.3y. It's negative 0.6. Divide. That's 2, but I'll prove it. Yep. So y is 2. Now with these percents, all you do for the label is milliliters at 50%. Okay, and then you can either just take 6 minus 2, which is 4, or you can put the 4 in for y. It's going to work out the same way. So x is 4 milliliters at 20%. All right, you have 4 to do on your own.